Computational fluid dynamics or CFD is essentially about computational solutions or numerical solutions of the governing equations of fluid dynamics and associated processes like maybe heat transfer, mass transfer and so on. Why such computational approach is needed is very clear, because the Navier-Stokes equation in their full form are highly nonlinear and they may be coupled strongly with other physical phenomena. Not only that, the geometry of the problem may be very complex, even though the equations may not be very complex, but property variations, geometry, multi-physics, that is maybe the physics of fluid mechanics is interfacing with physics of electrostatics or electrodynamics. So, all these phenomena make it very complex to solve these problems analytically. CFD finds wide range of applications starting from industry to academia, and it is very important for me to emphasize that this course is very relevant for industrial work. Typically industrial design work where CFD is used, maybe there are practitioners who are using CFD as a software tool, but one has to understand that the software tool is as good or as bad as your own inputs are. So, you have to design the problem properly in terms of setting the correct geometry, putting the correct equations and putting most importantly the correct boundary conditions, choosing the correct mesh for a problem solution. So, all these things require a great level of basic understanding as well as elaborate discussion on certain practical issues. So, I have designed this particular course with this balance of fundamental versus practical issues. So, we will develop the fundamentals of this course starting from the basics of variational calculus and basic principles, and then we will systematically try to figure out how to formulate or discretize the problems related to diffusion type of problems, convection type of problems and convection diffusion problems. So, which I mean the Navier-Stokes equation is a special subclass of this convection diffusion problems, with an understanding that the convection field may be the field due to temperature, the field due to concentration, or the field may be due to fluid flow itself. So, fluid flow equations we will study separately, because the other convection diffusion equations other than the Navier-Stokes equations are equations where the variables can be solved given the velocity field, but the Navier-Stokes equation itself contains velocity fields, and therefore it is a separate challenge to solve such nonlinear equations where pressure is a variable in addition to velocity, where there is no separate governing equation for pressure though. So, there are several challenges. We will also touch upon certain modern topics in this CFD research, and these include modeling of the unstructured mesh issues or advanced understanding of turbulence models and so on. Finally, we will be familiarizing you with a GUI based environment which is based on the in-house software written by my own students, and the whole idea is to make you familiar with the kind of environment, the software environment that you may encounter in your practice if you are using commercial codes or you are using open source CFD codes, how to deal with those things so that the course strikes a balance between fundamentals and application perspective. So, with this I believe that this CFD course will be very important to engineering students, science students, researchers and most importantly industry practitioners. So, I hope that this course will be very enjoyable and interactive, and I hope that all the participants in this course will become good CFD practitioners instead of participating in garbage out type of exercise if they go through this course. I wish all the participants very good luck in participating in this CFD course. Thank you.